Statistical process control is a proactive method for controlling quality during the manufacturing process. The control charts, as primary tool, help to identify changes in the process at an early stage, allowing to take timely actions before non-conforming products are produced. The actions usually intend to improve the stability of the process, but their impact needs to be analyzed and verified. In this video, I will show you a powerful approach how changes in process can be analyzed using our progression analysis function in SPC Visual for PowerBi. To reproduce this example, you need to install SPC Visual from Marketplace. To do so, please go to the App Source and search for SPC Visual from NextGen Industries. In our example, we want to use data from an Excel file, which contains two tables. The first table provides data with process signal which we want to analyze, including timestamp. The second table contains a list of actions, comprising action date, action name and action type. Action type will allow us to group actions of similar nature, making it easier to analyze trends, and to track the frequency of specific activities over time. Now we import the Excel file as new data source. Here we see both mentioned tables, and we just add them to our dataset. As next, we create SPC Visual. And assign the timestamp and values measure to our signal data from the Excel file. SPC Visual calculates automatically the distribution model and KPIs, such as CPK or PPK, according to default setup. How to change the default settings, especially how to set up specification limits, please check our other videos in our channel. As next, we try to assign actions to action log measure. But, as it can be seen from the error message, the direct assignment is not working. The reason for this is that date in actions table does not correspond to timestamp of the data table. The issue stems from defining actions on a daily level against signal data with minute and second precision. This is a common situation in day-to-day business. Now I will show you a possible solution, which will allow us to overcome this problem. The idea is to link an action to next closes record in the data table. To do so, we create a new measure within the data table. And we use following code snippet to create the link between action and data records. I will not go deep in detail of the code, but briefly speaking, it search for each data record the next action, where date is bigger or equal to the timestamp of the data record. At the end it returns the name of action, which then can be used within SPC Visual. I will post this code snippet in the description, so you can reuse it for your purpose. Now we can assign the new created measure to the action log parameter. As we can see, now the actions are shown within control chart. As next, we create a table visual, which will show us the action list. As next, we will go briefly through the options for the appearance of action log. First of all, you can disable or enable the rendering of the action. Further, you can set up if the text or action line should be rendered or not. Additionally, there's some options to change color and line appearance, and finally, it is also possible to adjust the maximal text size. As next, I will show you how changes in process can be visualized and analyzed using progression analysis function of SPC Visual. To do so, please select Progression Analysis tab within the menu. Progression analysis subdivides the data series into parts and calculates the KPIs, such as CPK value, for each part separately. By default, it separates the data series into 5 segments of equal size. Now we will look at the configuration options, which allow to adapt the segmentation type and the appearance. The visual supports 3 different visualization types: the bar chart, the violin chart, and the box chart. Additionally, you can select which KPI is used for the progression analysis. You can choose between CPK or CP value, as well as between lower side CPK or upper side CPK. The segmentation type is the most critical parameter in progression analysis. It defines the criteria by which data is partitioned into segments. In general, you can choose between count-based, time-based, and event-based segmentation. As first, we look at week-based segmentation. This option divides data based on the calendar week of the timestamp measure. As we can see, the color of graphs corresponds to warning or alarm state of KPI, which is calculated for each segment separately. This allows us to indicate the critical fragments visually, and also help us to analyze how the KPI progress over time. As next, we switch to bar chart visualization, which shows also the thresholds for KPI. The thresholds can be adapted to your needs within Apparent's Info Panel section. Now we switch to count-based segmentation. Here we can define the size of the segment based on number of data points. Please note that in this case the final segment will hold only the data that remains at the end, as the segments are filled in sequentially. Finally, we switch to action-based segmentation, which is also the main purpose of this video. In this mode, the segmentation is done based on events provided by action log measure. That means in this mode segmentation occurs dynamically, where each event log value change initiating a new segment. From the action log table, we observe that each entry forms a segment in the progression graph, spanning from the moment the action appears to the time the next one is recorded. An exception is first segment, which encompassing data that predates the first action. Now we can use the strength of PowerBi, which allows us to select specific actions and to analyze how the action impacts the KPI. But first, we choose the violin chart for the rendering. The advantage of violin charts is that they make use of density curves to approximate the underlying distribution. This makes it possible to track not only how the CPK value evolves, but also how the shape of the data shifts from one segment to the next. In this setup, we can choose the actions from our list and analyze dynamics between the time before and the time after the action. As next, we want to utilize the action type column. The idea behind it is to have the ability to select several actions which belong to the same category. That will allow us to analyze fluctuations between the actions of particular type. To do so, we create a button slicer and assign the type measure to the field option. Now we can adapt the style settings according to our needs. As a result, we created buttons which match different action types listed in our actions table. Now, with a single click on the corresponding button, we can instantly select all actions of the same type and analyze impact of actions on the CPK value. With this setup, we've achieved maximum flexibility in how actions can be selected, either one by one or grouped by type. This makes it much easier to dive deep into analyzing how different actions are connected, how they influence each other, and what impact they have on the overall process.